Alright, Integrated 1, the review for the Chapter 2 test. Basically a sample test. Number 1, the directions for both number 1 and number 2 are to simplify and to make sure that your answers are in scientific notation. I'll tell you right out of the gate that those directions will hardly come into play. It does pretty much mean that you can't just go on your calculator and figure out what this is and figure out what this is and just multiply them together and get a normal looking answer. I guess that's what the directions will mean to us. But here's what we're going to have to do. We have this number in scientific notation, 3 times 10 to the negative third power, multiplied with this other number that is in scientific notation. And in order to do that, what we're going to do is multiply the regular numbers. And by that I mean the 3 here and the 3 here. Those can be multiplied together to make 9. And then you can multiply 10 to the negative third power, multiply that to 10 to the 8th power, and because of the common base of 10, you can add the powers. Negative 3 plus 8, adding those powers, gets you 5. So this is how we want the answer to be, not, what would that be, 90,000, 900,000 actually, I think. So I guess what I was saying earlier was if you just kind of made this into a regular number and made this into a regular number, you could multiply them together, probably with the help of your calculator, and get 900,000. But we don't want the answer as 900,000. We want you to show your answer and make sure to keep your answer in scientific notation. Same thing over here. So in order to do that, to take two numbers that are in scientific notation and essentially divide them, because remember, fractions are essentially division. So this number in scientific notation divided by this number that's in scientific notation. In order to do that, we take the regular numbers, the 8 and the 2, and we just divide them. 8 divided by 2 is 4. And if you're going to do 10 to a power divided by 10 to a power, you can subtract the bases, just like we did last chapter. So 12 minus a negative 7 ends up being 19, because doing 12 minus a negative 7 is equivalent to doing 12 plus 7. Remember, like minus minus means plus. And as always, your calculator can back you up on, getting 19 for the power here. So again, this number is in scientific notation, and these two questions are actually being very kind to you, because remember, again, not that it's going to actually come into play here, but technically this number 4 needed to be between 1 and 10, which it is. This wasn't allowed to be like a 40 or a 0.4. So 4 is A-okay, and 9 is A-okay. If we would have ended up with like a 19 out in front, we would have needed to fix it, keep going, whatever. But again, these two questions are very kind in that regard, where the leading numbers are the right kinds of numbers for true, authentic scientific notation. But again, for some reason I feel like summarizing that, multiplying, you multiply the regular numbers and add the powers. Dividing, you divide the regular numbers and subtract the powers. Moving on. In numbers 3, 4, and 5, you want to evaluate, which means come to like a final actual value. Good thing they're telling us that x is actually 10 and y is actually 2. So in order to do x minus y, you substitute the values in for x and y. And so x minus y becomes 10 minus 2, which last time I checked was 8. Number 4, you're doing y minus x. That is different. That is different than doing x minus y. But same old game. Plug in the 2 for the y, plug in the 10 for the x. 2 minus 10 is negative 8. And number 5 says x times y. When you see xy like that, it means x times y, of course. And so we're going to do 2 times 10. Or why did I not write that as 10 times 2? Oh well, same thing. But let's play this little game. Whoa, that's funny. Yeah, anyway, it didn't matter. 2 times 10 would have got you the same answer because, you know, you're multiplying, and you can do that, but so 10 in for x, 2 in for y. Irregardless, you're going to get 20 as a final answer. Numbers 6 and 7, 6 or 7, whatever. You know, there might only be one of these questions on the test, but there could be 2. I guess the point is either these won't count, at least in 2018, or they could be bonus. You know? So possible bonus questions. But they certainly, at least in 2018, and if we're doing it the same way we did in 2018, these questions cannot hurt you. So number 6, which one's longer or larger? An inch of rope or a centimeter of rope? If you're at all familiar with these kinds of units, you know inch is longer. And a kilometer versus a mile. In number 7, kilometer versus a mile is larger. Sorry, that got cut off. That does say mile. So if you had to tell what was longer, a kilometer or a mile, you'd say mile. The other one I can think of that might be a potential question here of this kind, potential bonus would be, let's see, meter versus yard. So do you know what's a longer or larger measurement? 1 meter or 1 yard? Turns out that it would be a meter. 1 meter is larger than 1 yard. Okay, changing gears a little bit. Solve for x. Show all of your work, please. Otherwise, you could lose, well, just at the very least, you could lose points, extra points, if you're flat out wrong in your final answer, and I can't tell what kinds of mistakes you made in order to get that wrong answer. I'd have to probably assume that you had no clue what you were doing, and you would lose more points than you may deserve to lose. So, show all your work. For more reasons than one. It's just better anyway. It gives you more chance to get it right. Period. So anyway, here we want to get x by itself. So all that number 8 takes is to first add 7 to both sides. That's the first thing you would do. Then, and that, by the way, that would get you 5x remaining on the left side because that cancels out the minus 7. And the right side would become 20. 13 plus 7 is 20. Then you divide both sides by 5. So you got to do those steps in that order. First you get rid of the minus 7. Then you get rid of the times 5 by doing the opposite operations. And that'll leave x all by itself on the left side. And the right side finishes off as 4. X equals 4. Over here in number 9, same deal. Are we going to get rid of are we going to undo dividing by -5 first? Or are we going to undo the adding of 6 first? Because it matters. So we're going to do that first. And end up with this. So we get rid of that +6 first, but whatever we do to the left side, we also have to do to the right side. So the right side, 8 minus 6 becomes 2. Next, we multiply both sides by -5. That is what will undo and cancel out division by -5. And so that leaves x by itself, and the other side is -10. Number 10, okay, what do we do first? Do we get rid of this 10 or this -2 with the x? And again, the 10 is not negative. This negative sign does not go with the 10. So that 10 is positive 10. That is a positive 10, and that's what we're going to get rid of first by subtracting it. The common mistake there is to, oh, I see a negative. I see a minus sign. So I got to, no, this minus sign is with the 2, not the 10. And that's a positive 10. And so that'll get rid of the 10. And the right side will now be -2x. That negative stays with the 2, because it's -2 times x. And so next we divide both sides by -2 to leave x all alone. And the left side finishes it up as -10. At least the class I'm actually teaching as I make this video in the year 2018, in September, late September of 2018, my current class insists, that's too strong of a word, but they like writing it as x equals -10, not -10 equals x. And I don't blame them, I kind of agree with them. But anyway, I would be okay with this answer, and I would be okay with that answer. So both are okay. In this problem, number 11, this is a little bit different, okay? So the first thing you would actually do is multiply this one by 5. So if the fraction looks like this, we actually want to get rid of that 5 first. And so we multiply both sides by 5 to leave x plus 9 on the left. The right side becomes 20, because whatever you do to one side, you got to do to the other side. And now we would, of course, subtract 9 from both sides to get x all the way USA, all by itself on the left. X equals 11. Number 12, a fancy word problem. A bike rental shop charges $15 plus $7 an hour for renting a bike. If James paid $36, that'd be total, $36 total to rent a bike, how many hours did he pay? So I want to point out that this is what they're asking you to find. That is what is not known. That is what you let a variable represent and fill in for temporarily. Whatever is not known, you assign a variable and you put that variable in an equation. So we're going to say that h represents the unknown number of hours. Makes sense, h, because hours starts with h, you know. And then you have to know that the equation goes something like this. Because whatever the number of hours would be, you would multiply it by 7, because 7 is how much money costs per hour. So naturally you would multiply the 7 to whatever the number of hours was. So that's 7h. And then you would tack on this one-time charge of 15 to equal 36. So that's what the equation would look like. And then from there you just work on solving for h, getting h by itself by subtracting 15 from both sides and then dividing both sides by 7 in that order to get a final answer of 3 hours. And I guess I'll follow up and end with a comment like, could you have done this without actually writing out an equation quite like this and solving for h? Yeah, you could have done this, okay, just by common sense, like working backwards from the $36 to figure out how many hours it must have been. But I don't know. I'm just going to say that when there's a lot of reasons I can mention, and I probably have in class. Why like writing out an equation is the best way, the most reliable, exact way. But let's move on to number 13. Find the mean, median, mode, and range for these 6 numbers: 23, 45, 89, 71, 98, 23. So you're going to have to know going into the test what all these words mean. The mean is the same as average. You would add up all these numbers: 23 plus 45 plus 89 plus 71 plus 98 plus 23. You would get a sum. You'd get an answer for that. And then you would divide by 6. So to get the mean, you add up all the numbers and you divide by how many numbers there were. And make sure you're able to get this for those 6 numbers. The median means the middle number. And you can't find the middle number unless you put them in order. So over here they are in order: 23, 23 again, 45, 71, 89, 98. And in this case, the median would fall in between 45 and 71. And that means that there's 3 numbers and then another 3 numbers, and so the median actually falls in between the first 3 numbers and the second 3 numbers, because there was an even number of values. That's what happens. So we have to go in between 45 and 71. And it already says here 58. But in order to do that, I'll actually write this. I'll take the moment to actually write down the mathematics that you might have to actually do. Because sometimes, like I've said in class, sometimes it's easy, like super easy, to figure out what number is between these 2 numbers. Like, what if it was like a 9 and an 11? And you said, like, what number is exactly in the middle of 9 and 11? You don't need to be a genius to figure out that that's 10, right? But I can totally see 45 and 71. You would actually find the average of those 2 numbers by adding them up and dividing by 2. And that's where 58 comes from. 58 falls exactly in the middle of 45 and 71. The mode is the number that occurred the most. And so 23 happened twice and everything else was once. So the mode here is 23 because it occurred the most times. The range is like the span of the values. Like we're ranging from 23 to 98. And so I don't know if it says this behind the box. I'll write it here. What you would do is the highest number minus the lowest number to get the range of 75. Okay? That's how you get range. highest number minus the lowest number. And then there's one of these questions. I think just one of these questions. Yeah. So what do we do if they're giving you the final average or the final mean, and they're saying, like, let's see, 1, 2, so it looks like there's 6 numbers here, and they're basically asking, what would the 6th number have to be in order to get a final average of 4, final mean of 4? And so here's what you do. Or here's one way to do it. You set this up as, well, you would do, in order to find mean, you add up all the numbers, including the number you don't even know yet. We'll just call it x for now. I mean, it's already called x here. And we're going to divide by 6. Because there are 6 numbers. We don't know one of them, but we're going to add up all 6 numbers and divide by 6, of course. And all that is supposed to equal 4. Because 4 is the final average. And so now we just have to kind of work backwards solving for x. Okay? And actually the first thing we're going to do is multiply both sides by 6 to kind of like, we're kind of doing this backwards, dividing by 6. So multiplying by 6, kind of undoes that. And so this side becomes 24, and the 15 came from just doing the 1 plus 2 plus 3 plus 4 plus 5. All these numbers are together right here. They're going to be just 15. So multiplying both sides by 6 gets rid of that 6, and adding all those numbers together, you get the 15. And now all that's really left to do to figure out what x would be, if you were to get it by itself, is subtract 15 from both sides and end up with 9. So in order to have an overall mean of 4, that 6th number would have to be 9. And that's your final answer, 9. Use the following information to answer the questions. Well, it looks like the information you were given was a list of what? 10 numbers? 5, 8, 10, 11, 14, 16, 17, 18, 19, 20. So you take those 10 numbers and you find the first quartile, the median, okay. This has probably been fixed on your handout, but I guess not on my active chart file at the moment. So your paper most likely says third quartile for that one. So we have to find the first quartile, overall median, third quartile. Please remember, people, that first quartile is another name for lower quartile, which is another name for lower median. So essentially this is finding the lower median. And don't forget that third quartile is another name for upper quartile, which is another name for upper median. So anyway, here's what we do first. We find the median, which turns out to be in between 14 and 16. To find the true middle, we have to go in between 14 and 16 to get 15. And then what's essentially the lower median, you take the median of just these 5 numbers, 5, 8, 10, 11, and 14, and the middle number is 10, one of the numbers. And what's essentially the upper median, just looking at 16, 17, 18, 19, and 20, finding the median of just those 5 numbers, it turns out to be 18. And then the extremes, well, gives it away here. The lowest number is 5, obviously, and the highest number is 20. All right? Lowest number, highest number. And then in part C, you take that information, like literally all this information, this number, this number, this number, and these two numbers. Those are the values, those are the measurements, per se, that you use to draw a box and whisker plot. Because remember, the lower median, which again is the lower quartile, and it's the same as the first quartile, that's going to be where you draw the left edge of the box. The right edge of the box is going to be your upper quartile, upper median, third quartile. And the line inside the box needs to line up with the overall median. And then you draw the left whisker out to the, right here, look, the absolute lowest number, and you draw the right whisker out to the absolute highest number. And, I mean, let me say that the way this number line was labeled, there really shouldn't be any doubt that this was supposed to be 5. There really shouldn't be any doubt that this is lining up exactly with 10, and that this line is lining up with 15, and so on and so forth. But it definitely never hurts to label your box and whisker plot, and just to be absolutely sure that, like, someone who's reading it doesn't have any doubt what the, where the left edge of your box is lining up with compared to the number line. All right? So label your numbers up here. And the final question says, in a box and whisker plot, if both of the whiskers are much larger, as they say both, if both whiskers are much larger than the box, what does that tell you about the data? Well, I guess the length of the whiskers, don't they pretty much exclusively depend on, maybe not exclusively, but I mean, really, the length of the whiskers depends on what the absolute lowest number is and what the absolute highest number is. That's what dictates how, like, where the whiskers go, where the left whisker goes all the way out to the left, how far, and how far right the right whisker goes is just the absolute lowest and the absolute highest numbers. Like those two numbers. So if your whiskers seem like abnormally long, that would mean we have a couple of outliers. That's the key word I would need for this answer. You have like an outlier that's abnormally low compared to the rest of the data, and you would also have an outlier that's abnormally high compared to the rest of the data. And that's probably all I need to go over. That's the last question. Happy studying.